So now we're going to save this plate and create the runners for this shooter. So we're going to name this shooter plate, and keep that as in our shooter folder. So we're now going to open a new file and create a new sketch. We're going to make a rectangle with 2x1, and then we're going to use an offset and offset this negative 0.125 inches, giving it a 1/8 inch wall thickness. And we're going to finish that sketch and extrude this. We're going to extrude this 8 inches, I believe. We are going to save this as runner or shooter runner. And then we're going to have to give it those holes in the top and bottom. So we're going to create another sketch. Oh, that was in the wrong plane, so we're going to have to delete that one. We're going to create another sketch on top of this piece, and we're going to give it a circle here. And we're going to give it that same dimension as earlier, 0.201. And then we're going to dimension it 1/2 inch from this edge and 1/2 inch from this edge. Now, this is pretty standard measurements. Everything will have a 1/2 inch grid, essentially, from parts that we buy from our suppliers or parts that we make. And now we're going to extrude this hole through this plate. We're going to do -2 and use the cut operation in this case to cut out that hole. Now, we only have one hole, which is an issue, but what we're going to do is use a rectangular pattern. Now, in this case, you'll notice that I'm doing it after sketching instead of before sketching, which is easier, which I'll explain in 1 second. We're going to use a feature because we are doing a extrude function, and we're going to grab that extrude function, select the axis, which is here, and then we're going to make this spacing. We're going to make the spacing between these exactly 0.5 inches. Exactly 0.5 inches. And we're going to do 7 of them. No, I said 15 of them. 15 of them, I believe. What is going on here? There we go. And we will have all of the holes that we need for this. So the reason I did the rectangular pattern for the feature instead of within the sketch, if we were doing all of these holes by just the sketch, we would have had to select each and every single one of those profiles to extrude, which becomes very tedious if you're doing a lot more holes in this. So it's much easier to be able to do one hole and then pattern out that hole instead of creating a bunch of circles and then select each of those circles to extrude. So we're going to save this, and we're now going to create a new file to assemble this shooter plate and shooter runner in. So we're going to import this by dragging and dropping or right-clicking and inserting into current design. We're going to click OK, and we're then also going to grab our shooter runner. We're going to move this so it's kind of more accessible, and now we're going to joint this piece to our shooter plate. So we're going to grab this hole here, and we're going to joint it to this end here, which is currently not in the orientation we want. We kind of want this piece to be on top of and also rotated 90 degrees. So we're going to flip this joint so it's now on top of this, as you can see here. And then we're going to rotate this 90 degrees, or in this case, -90. And we're going to click OK to accept that. Now we can see this joint has been created. This is a rigid joint number 1, as you can see in relationship or joints under relationships. And we can see all these holes line up here. What we're going to do to start off with is just get rid of that visualization of that joint, because we do not want to see those on our final model. We will end up with hundreds of joints and we do not want to see all of them. We're going to import a second one for the second side here, and we are going to joint it using that same method. Now we are going to select this place, and it does the same thing here. So we're going to flip this over and joint it at 90 degrees. But if we have lots of these instead of just two, what we can do as well is we're going to undo this by deleting that. We can use the duplicate with joints button, and we're going to select this component that we want to duplicate, and we're going to select the point at which we want to duplicate it with. So if we select this point, it will duplicate exactly into that same spot. And if we click OK, it will create that joint, rigid number 3, because we deleted the other one. And now we have that same runner. Next, what we're going to do is joint another shooter plate on top of here. Now, this one I'm going to do without the duplicate joints because I believe it will have to get flipped, and it's just easier this way. So we're going to grab this joint here, or this hole here, and we're going to joint it to this corner down here, and flip and rotate to 70, I guess. And this will line up perfectly with these holes. So now we have this sandwich shooter, kind of similar to our 2024 Crescendo robot. So we're going to save this, and we're going to save it as indexed at 0. We're going to create our shooter, and this is going to be our main subsystem part for this shooter subsystem. So we're going to save that, but we're going to run some quick calculations on this and use our inspect feature with our center of mass again. So we're going to select all of our components and click OK, and it's going to calculate our center of mass to be right there. Now, one thing is that we actually never reweighted these extrusions. So currently, if we select our shooter runners and look at our properties, we're going to notice that these are made out of steel, which is not what we want. These are going to be made out of aluminum in the end. So we're going to close this up, and we're going to go back into our shooter runner folder or file and modify the physical material. We're going to go into our metals and select a aluminum alloy, which is called 6061. So we're going to drag and drop that over here and close that up and save this file. Now this piece has been set to aluminum, and it will reweight this correctly. So if we take a look at where our center of mass is right now, and we use this button to update our child component, we'll notice that that center of mass shifts a decent amount just with that one component. So when we have hundreds of components and all of them are weighted correctly, we can get super accurate measurements for where our center of mass is and what our total weight's going to be. So now if we take a look at these and look at the properties, right now we're just looking at just the shooter plate. Let's see if we can do all of them. There we go. If we select the shooter V2, the whole thing, we get a mass, which is 36 ounces, which is very helpful when we are calculating the mass of our robot and trying to keep it under a certain amount of certain restrictions, which FRC sets for us.